my introduction. As Nikki has just put on, we are recording this. It will be available only to PfL members, and I'll put the link in the forum in the thread that I put in about this presentation this evening. So this evening I am so excited. We're always being asked about the nutritional benefits of meat and also why pasture-based meat is so much better. And we've got two worldwide acclaimed speakers today. We've got Professor Alice Stanton and Professor Stefan van Vliet talking. So Alice is going to go first. She's a professor of cardiovascular pharmacology at the Royal College of Surgeons in Ireland, and also the director of health at Devonish, who specialise in sustainable food solutions. She's published well over 130 papers. She's had multiple awards, but recently she's also been one of the academics calling for the authors from the 2019 Global Burden of Disease Risk Factors that came out in the Lancet then to provide evidence to show why they suddenly had this dramatic increase in the number of deaths accounted for unprocessed red meat, which just didn't seem to stack up. And hopefully she'll bring some of that in. So as I say, Alice is going to be talking on why meat and dairy is and how much is good for us. And then Stefan is going to be talking later. Please, can everyone keep their muted, and if you want, keep your microphone on. As I say, it is being recorded, and if there's sound in the background, it just disrupts everything. If you have any questions, please put them in the chat. We will go through Alice's and Stefan's presentations and then come to the chat rather than break in the middle. And I will ask the questions again, so we don't have too much of a delay, because we've got so many people in today, which is great. So Alice, I'll shut up now and over to you.
Yes, good evening. I'm delighted to be here, and I'm just going to share my screen and then start to talk. And I think you should be seeing a title slide at the moment. If you could just...
Yeah, that's absolutely perfect. Thank you.
That's great. Okay, well, what I'm going to talk about is how much red meat and dairy should we eat. And I'm also going to talk about the importance of using transparent, evidence-based health metrics when we're addressing that question, because that will impact on food policy decisions. As Penn has alluded to, I'm involved in a battle on a number of fronts related to that. My disclosures, so I'm both an academic and an employee and owner of stock of Devonish Nutrition, and I'm very definitely an omnivore. I'm going to start with what is the definition of a healthy diet. And a healthy diet needs to do two things. It needs to protect against malnutrition in all its forms, as well as protect against non-communicable diseases, such as diabetes, heart disease, strokes, and cancers. And we're really not doing very well. We know that almost 1 billion of our 8 billion on the world are chronically undernourished, insufficient calories. These women, children, and men go to bed hungry, and that is a shame, and we should be ashamed that that is actually happening. We should also be ashamed that actually almost 2 billion are eating excessively, are overweight or obese. And that is definitely contributing to non-communicable diseases, to heart attacks, strokes, and to cancer. Obesity is one of the strongest risk factors for cancer, for about 10 different types of cancer. What's less well known is that about 1/4 of us, and probably more, suffer from hidden hunger. And that's where our diet is adequate, is sufficient, or more than sufficient in calories, but is inadequate in quality terms. In particular, insufficient high quality protein, insufficient minerals such as iron, zinc, iodine, selenium, and vitamins such as B12, vitamin D, vitamin A. Now, most of those nutrients that I've just mentioned are either solely got or are mainly or are best got from animal source foods. If you look at the left-hand side of the slide, and you may not be able to read all of the various foods that are listed down in this table, but what it shows is the top foods that are rich in commonly lacking nutrients, those minerals and those vitamins. And of the top 20 foods, 18 are animal source foods, either meat, fish, eggs, or dairy derived. And you can look at it another way, and that's what is happening on the right-hand side of the slide. On the horizontal axis of both of these graphs are the percentage of calories that are derived from animal source foods. And you can see that if animal source foods provide less than 30% of the calories to the diet, in actual fact, vitamin deficiency becomes more and more common, up to 80% prevalence with very low intakes of animal source foods, so 80% deficiencies for vitamin A. Similarly, for the key minerals, calcium, iron, phosphorus, and zinc, the lower the percentage of calories that come from animal source foods, the more likely is there a deficiency. And that also happens for protein and indeed for long-chain omega-3 polyunsaturated fatty acids. But that's levels. Let's look at a real endpoint that means something to the average person. And one of the worst adverse outcomes of nutrient deficiency is childhood stunting. And that's not just small children, that's children that are damaged both physically and mentally. So the children that are stunted are less able to engage with primary school, lesser academic achievements, lesser career options, and therefore a lesser ability to provide nutrients and housing for the next generation. So you get a vicious circle forming. In the pink-coloured countries, more than 1 in 3 children are stunted. That's in sub-Saharan Africa and southern Asia. They're the exact same countries where meat intake is least, where dairy intake is least, and where seafood intake is least. Now that's an observational study. Let's look at the gold standard proof of the impact of a various factor. And that's a randomized controlled trial. And that's exactly what happened in Kenya about 10 years ago. A group of researchers took 12 schools and they randomized these national schools to 4 different feeding regimes. So 3 schools got a plain vegetable stew each day that the children attended the school over 5 semesters, so almost 2 years. The next group got the vegetable stew plus dairy. Same calories, actually, same energy provided to each group. And the next group got a vegetable stew with meat in it, red meat, in fact. And the last group, unfortunately, got no additional nutrition. So they were the pure control group, but you can also regard the vegetable group as being the control group. And they looked at academic achievement in 7 different subjects, so arithmetic, English, 2 national languages, geography and science, and the arts, over the 5 semesters. On the extreme right-hand side is the average scores of all of those subjects. And in fact, those that got the additional meat were on average 17% higher than the control groups. The milk group also did pretty well, plus 13%. The vegetable group were only marginally better than the actual control group. That's a huge difference, 13 and 17% in average scores. Can you imagine if a whole class were on average 17% better than a school down the road? It's a huge difference. And it's not only the young that benefit from animal source foods. These are 2 studies that were published in 2022, which showed that total meat intake led to a longer life expectancy, as did a total animal protein intake, and that was far better. You were more likely to live longer and live with less disease. But I'm a physician, and I don't want climate change to happen, because climate change would pose potentially catastrophic threats to human health. So heat and extreme weather events, droughts and desertification, more vector-borne diseases such as mosquitoes bringing malaria to the more of the northern hemisphere, and increased poverty, inequalities, violence, and migration happening because of extreme heat, making certain areas of the world unlivable in. So I actually welcomed one of the first attempts to balance human dietary needs and planetary boundaries, or the environment. And this was the Eat Lancet Commission reference diet, which was published in The Lancet in 2019. I agree with the doubling of intakes of fruit and vegetables, legumes, nuts and seeds. We're not eating enough fruit and vegetables. We need that too for essential nutrients. But the Eat Lancet reference diet recommended a halving of meat and dairy and an even more dramatic decrease in red meat consumption. They said that if everyone moved from the standard Eat Well diet, which we're not adhering to very well in Britain or worldwide, how many of you are actually eating the 5 portions of fruit and vegetables that are recommended? How many of you will be willing to move to the 10 portions of fruit and vegetables that are recommended in the Eat Lancet reference diet? They said that such moves would save 11 million non-communicable disease deaths per year. And that's probably correct, but it's not due to the reduced meat and dairy intakes. It would actually be because of the reduction in calories, the reduction in salt, and the increase in fruit and vegetables that are mandated by the Eat Lancet reference diet. Furthermore, the Eat Lancet reference diet authors did not take any consideration of the nutritional deficiencies that will be caused by a universal halving of meat and dairy intake. And they also didn't consider the impact of the ultra-processed nature of the alternative foods that are available. So the currently available plant-based meat and dairy alternatives are ultra-processed foods. They're really high in added sugar, salt, and multiple cosmetic additives. The Beyond Burger, actually, it does have the same protein content as steak, but it has 5 times the salt, and its protein quality is unlikely to be as equivalent to that of steak. The jackfruit and mushroom products are even worse. Even more sugar and salt, multiple additives, and less than 20% of the protein, these kind of products here. And you really don't want to be feeding your children unsweetened almond milk. Twice the salt, 1/8 the protein and 1/4 the zinc. Ultra-processed foods are really strongly associated with obesity and salt excess, which actually are the two leading dietary risk factors for heart attacks, strokes, and cancer. And it's not only the plant-based alternatives that we need to consider, the cultured meats and the precision fermented animal-free dairy products that are currently on the market to a limited extent, they're also ultra-processed food filled with additional additives. Despite the reservations that I've just expressed concerning the Eat Lancet reference diet, and others have expressed, there's been a wealth of further recent publications that are recommending dramatic reductions or indeed exclusion of animal source foods from the human diet. This one here led to this headline: cutting out red and processed meat was one of the most important shifts, adding on average 1.6 years to a young woman's lifespan and 1.9 years to a man's. This is just not correct. Now, I'm not going to go through all of the publications. I'm going to focus on one very important one, the Global Burden of Disease Risk Factors Study for 2019. And the reason I'm going to focus on that is because most, if not all of the other studies, either use the data or the same analytic techniques as does the Global Burden of Disease 2019 study. Furthermore, the studies published by the Global Burden of Disease collaborators are hugely influential. So they're quoted by and influence the policies of the Food and Agricultural Organization of the United Nations, the World Health Organization. For me, it's important that they definitely influence the European Commission. Farm to Fork strategy quoted their data. The National Food Strategy for England quoted actually the 2019 data, and I'll show you what it said in one of my later slides. Eat Lancet reference diet actually is based on Global Burden of Disease 2017 data. Now, they're not shy. They recently self-described themselves as the de facto source for global health accounting. And since that's the case, it's really important that their data is transparently evidence-based, and it really hasn't been. What I'm showing you here on this slide, and it's quite a busy slide, but it's an important slide, is the comparison of the 2017 analysis and the 2019 analysis. 2017 is in navy and 2019 in red. For excessive dietary risk factors and how many deaths they cause, and for deficiencies. And you can see the top excesses are diets high in calories and diets high in salt. The top deficiencies are child and maternal malnutrition, which we've talked about, and diets low in whole grains, fruits, seeds, vegetables, and omega-3 fatty acids. Diets low in milk actually do cause deaths, but that's underestimated by the Global Burden of Disease, both in 2017 and 2019, because they only counted the protection against colorectal cancer. Now here in the left-hand slide, I'm showing you how much milk or dairy products is consumed by the world's population. And in fact, the vast majority are consuming less than 300 grams of milk a day. So less than 1 helping a day. A lot are consuming much less than that. But yet, up to 850 grams a day actually provides increased protection against colorectal cancer. Not only does it protect, does dairy and full-fat dairy protect against colon cancer, it also protects against cardiovascular events. So a 32% reduction in cardiovascular events, that's heart attacks and strokes, and a 25% reduction in total mortality. So 25% less people die if they're consuming 2 or more servings of full-fat dairy. That was an observational study reliant on self-report of dietary intake of dairy. But there's actually been a further study which was published in 2019, which actually looked at a biomarker, so tested whether people were being accurate in their reporting of how much dairy they were taking in. So serum pentadecanoic acid is mainly only available through dairy intake. So therefore, the amount of it that's in blood actually is a biomarker of how much dairy is being consumed. The higher the intake, or the higher the level of this biomarker of dairy fat intake, the less likely you were to have a heart attack or stroke. So cardiovascular disease risk was lowest in those that had the highest levels of this fat intake. So this is a confirmation of the benefits of intake of dairy. A quick word on omega-3 fats, which mainly come from oily fish. The benefits or the protection afforded by seafood omega-3 fatty acids was reduced in the 2019 analysis from over 1.5 million deaths saved in the 2017 analysis down to only 500 deaths saved. And I can't understand how that occurred. They're only accounting for protection against heart attacks and strokes, but actually the long chain omega-3 polyunsaturated fatty acids, EPA and DHA, are hugely important for brain development during childhood, vision, muscle and joint health, and they also protect mental health in later lives. And only 20% of the world is taking in the recommended amount of EPA and DHA. So I think the 1.5 million deaths that are resulting from omega-3 deficiency is more correct than the reduced value. For the rest of this talk, I'm going to focus in on unprocessed red meat. In the 2017 analysis, Global Burden of Disease said that 25,000 deaths were occurring worldwide due to diets that were excessive in red meat. That was increased dramatically, 36-fold, up to almost 900,000 deaths in the 2019 analysis, without providing any direct evidence for this massive increase. Really, 25,000 deaths on the global scale with very excessive red meat consumption is very small print, but one could not ignore 900,000 deaths being attributed to unprocessed red meat. This is what we are consuming worldwide in unprocessed red meat. So the vast majority are consuming less than 75 grams a day. So that's the range that is relevant to look at risk of red meat. Higher income countries, particularly in Eastern Europe and Western Asia and South America, are eating a lot of red meat. So they are accounting for this kind of area here. Western Europe is around here, so 25 to 50 grams a day. And then some of the poorer countries are consuming very little red meat per day. Global Burden of Disease 2019 study said actually the optimal intake, which they termed the theoretical minimum risk exposure level, but I think you can regard it as the optimal intake of red meat. It previously had been 22.5 grams per day. And they said, well, actually, we have looked at the evidence and we say it should be 0 grams per day. They didn't provide any evidence for this change. They performed their own systematic reviews and didn't show them to us. And they said that they had found sufficient evidence for a causal relationship. That means that red meat intake was causing colon and breast cancer, diabetes mellitus, ischemic heart disease, that's heart attacks, and the two types of stroke, hemorrhagic and ischemic stroke. They added up all the deaths and illnesses that were being caused by red meat, these 6 types of deaths, and they said that the relationship between red meat intake on the horizontal axis and risk of dying was as so. That it increased from the first mouthful of red meat, was statistically significant at 10 grams. So even these people here eating 10 grams per day of red meat, that's 70 grams per week. That will be 1 steak every 2 weeks. They are at increased risk of death from these 6 endpoints and continues to increase throughout the relevant range of red meat intake up to 80 grams a day. Well, that's not what the big cohort studies show. So what I've shown here are the 10 studies from large published cohort studies that looked at red meat intake and risk of dying. Not a single one of those 10 studies actually showed an increased risk at less than 25 grams per day. The global study, the PURE study from 21 studies, or 21 countries, 2 European studies and 4 Asian studies showed either no increased risk at all, such as the PURE study, or that risk only rose above 75 grams per day. It was only 2 North American studies that actually showed an increased risk of borderline significance between 25 grams and 75 grams of unprocessed red meat per day. Because of our concern about the disparity between published evidence and what Global Burden of Disease 2019 was reporting, we wrote a letter to The Lancet, which is what you do if you have questions or disagreements with published papers. That was 6 professors from 6 different universities, from Ireland, from the UK, from Belgium, and from Australia. And we asked 2 key questions. Where's the evidence? Where are the systematic reviews reported according to the 2 guidelines, the PRISMA statement and the Gather statement, that they're required to be reported by? And where's the evidence for changing the optimal intake of red meat from 22.5 grams per day to 0? And we also asked them, what about the additional deaths and illnesses that would occur if everyone stopped eating red meat? So what about the additional deaths and illnesses from iron deficiency anemia, from elderly fragility, and from child and maternal malnutrition? It took us 9 months to get our letter published. A month later, in March 2022, we did get a response from Christopher Murray from University of Washington, Seattle, on behalf of the Global Burden of Disease Risk Factors collaborators. And they admitted errors. However, they didn't answer our key questions. They admitted that there was no evidence supporting a relationship between red meat consumption and subarachnoid hemorrhage. And in fact, there was a protective relationship with hemorrhagic stroke. They said, actually, in fact, the relationship between red meat and various outcomes, including heart attacks, is relatively weak. And in fact, we were wrong to set the optimal intake of red meat to 0. We will do better in future global burden of disease analysis, but that's not good enough, because if there are errors and these are confirmed, what you have to do is immediately correct those errors. And that's all the more important because of the massive influence that global burden of disease reports have. This is required by the Lancet guidelines and the various committees that control or regulate publication of scientific and medical papers. We were very pleased that a couple of months later, we were joined by authors from the Academy of Nutrition Sciences and from the World Cancer Research Fund. The World Cancer Research Fund is hugely influential in determining the risk factors for cancer. They are the Bible in that area. So what they said was they supported us. There was a need for further clarification, justification, or reconsideration of the optimal intake of zero from processed red meat. They used terms like implausible, lack of transparency, troublesome, unsupported by the evidence, and they said, neither we nor any other international organization recommend complete avoidance of meat. We've had considerable media and scientific interest. I'm not going to go through all of those, but I am going to highlight one tweet from Professor Gordon Guyatt. Now, Professor Gordon Guyatt is from McMaster University in Canada, and he's one of the founders of evidence-based medicine, because we don't practice medicine based on theory or thoughts or hypotheses. We practice it based on data, on evidence. What he said was, calls for evidence remain unanswered, even in the latest author's response. Big problem. He is very influential. And not surprisingly, in October, there was a series of papers published by the Global Burden Disease collaborators, this time in Nature Medicine, another major medical journal. And the conclusions are now very different for unprocessed red meat. They confirm no or very weak evidence that unprocessed red meat is associated with any increased risk. The evidence is insufficient to make any strong or conclusive recommendations concerning reduction of red meat intake. And this is a technical term, so the 95% uncertainty interval for the TMREL of unprocessed red meat is very wide, ranging from 0 to 200 grams per day. That actually means that optimal intake of unprocessed red meat could be as high as 200 grams per day. Now, I'm not recommending that. That will be an unbalanced diet, but there is no evidence against it that up to 200 grams could actually cause any harm. There are consequences to non-correction or retraction of the Global Burden of Disease Risk Factors study, because there are further publications that are citing this study. Over 2,000 scientific papers have cited this risk factors study. Now, not all concerning red meat, but there has been some that have used their data, including this very influential other Lancet publication in October of last year. This is the Lancet Countdown on Health and Climate Change. So it looks at all aspects of health and climate change and their interactions. Now, their major finding was fossil fuels are damaging, but one of its other headline findings was in 2019, 2 million deaths were related to red and processed meat and dairy consumption. Now, the red and processed meat consumption was very much based on Global Burden of Disease 2019 data. The dairy consumption is interesting because not only is red meat being challenged, but also ruminant dairy production is now being challenged. So they said that excessive dairy consumption was excessive calories was leading to obesity, and therefore that was causing deaths. Now, in fact, as I've already shown you, They said that you shouldn't be having more than one full fat dairy serving a day. But I've already shown you that the more dairy you eat, the more protected you are from mortality, from heart attacks and strokes, and from colorectal cancer. And interestingly, actually, the more dairy you take in, certainly up to 600 grams per day, the more protection you have against overweight and obesity, is what the most recent evidence published in 2022 shows. This is where global burden of disease was quoted in the National Food Strategy in the evidence document. So they used global burden of disease 2019 data, and they said that diets high in red meat and high in processed meat were causing 4 times the number of illnesses as diets high in salt. This is just not correct. So my last slide, the take-home messages. Every one of us should be extremely wary of global health estimates that are not rigorously or transparently evidence-based, and that ignore the protections against nutritional deficiencies and chronic diseases afforded by animal source foods. So the relationship between red meat intake is probably mirror J-shaped. Too little results in deficiencies. Too much, there may be a small increase in colon cancers and diabetes mellitus. It's relatively small. It's not certain whether it's a direct effect of red meat or whether it comes from excessive calorie consumption or an unbalanced diet. The majority of the world are not eating enough dairy nor long-chain omega-3 polyunsaturated fatty acids. I haven't talked much about them, but I'm very happy to do so if you're interested. And finally, consumption of nutrient-rich animal source foods in appropriate evidence-based quantities should continue to be included in national and international guidelines for a healthy, balanced diet. And in order for that to continue, we need transparent evidence-based data. Thank you for your attention.
Thank you so much, Alice. That was brilliant. I really enjoyed it. I think what we're going to do is as I say, is move straight on. So if you could stop sharing your screen.
Yeah.
And we've got some coming in. Right. So that was fantastic. So now we're going to move to Stefan, who he's already put his title slide up. So Stefan is based at Utah State University. He routinely collaborates with farmers, ecologists, and agricultural scientists to study the critical linkages between agricultural production methods, the nutrient density of food, and human health. Some of you may know he's collaborating with the Bionutrient Institute, the Bionutrient Food Association, to define what nutrient density in beef actually means. And some of our PfL farmers sent some samples to Stefan last year through Nikki. So I think that's part of that study. And what it's hoping is whether over time that his research will help uncover how the nutrients in beef actually vary depending on the management, genetics, soil, forage, and the microbiome of the animal. And so how we grow our animals and how our soil health is, which a number of us are very fascinated by, is going to impact, hopefully, maybe on certainly animal health and maybe also human health. So Stefan, over to you.
All right, thank you for that lovely introduction, and thanks so much for the presentation earlier, Alice. Really nicely set the stage, and happy to see that as a Dutchman who consumes a lot of dairy, I should be in the clear. So my lab research interests, I mean, work at the nexus of agriculture and human health. I've always been very fascinated by sort of building health from the ground up. Through my time in medical schools, we never really collaborated with farmers or agricultural scientists, but we were mostly treating diseases of dietary origin. So to me, that didn't make a lot of sense. So as I moved through my career, I started to try to link the two. So within my research group, we have 2 major interests. It's nutrient density profiling, and then we take the foods that we could collect from the field, or it gets sent in by farmers, and we run randomized controlled trials to see, at least look at biomarkers of human health. So I'll mainly talk about our meat nutrient density project today. We have multiple sort of lines of research going on there, but the main one is also unique with the Bionutrient Institute. We do some work with the Turner Foundation on bison as well, and we're studying milk as well. But we just want to basically get solidly define what nutrient density is. Usually it just means more micronutrients, vitamins, phytochemicals, more omega-3 fatty acids per given unit of product. So if we have twice as much vitamin B3 in 100 grams of meat, then we can say it's more nutrient dense typically. So we do deep metabolic profiling. We go beyond what just appears on the nutrition facts panel. We sometimes tend to dumb down foods to protein, but foods are much more complex than that. And we try to link health across this spectrum. So soil samples is part of our collection. We typically look at carbon and respiration, minerals, and available nitrogen. We also take forage samples and feed samples. So we're really trying to define everything in between what people would consider regenerative or agroecology, more nature-based solutions, so within grazing systems. But here in the US, we obviously also have a large feedlot system. So we do both forage and feed analysis, and a lot of farmers are also sort of on a spectrum of that, where they may include some feeding of hay and grain byproducts during the winter or the finishing phase. So we collect forages, we collect meat, and then we run this through a mass spec. So process these in the lab. We do a mass spec analysis. What a mass spec can do, it can basically allow you to look at a large number of compounds in a sample. It's the same what people use for drug testing in athletes, for instance. So, but we use it for specific compounds in foods, as well as human blood or urine to look at biomarkers of their health. So we identify these metabolites. We get a large data outputs. We cluster these compounds according to structural similarity. It might be phenolics, terpenes, which are phytochemicals, or amino acids, fatty acids. And we basically overlay those. So if we have more phenolics in the plant, do we see more in the animal? Do we see more in the human? And metabolomics, we really go beyond proteins and fats. More traditional nutrition analysis, if we pick up meat from the grocery store, in the US at least, we see protein on there, we see total fat, saturated fat, cholesterol, and then 4 vitamins, minerals, which is not very much. And it doesn't tell you about the complexity of the food. So, and even the USDA database only tracks 150 components and forms the basis of our nutritional understanding. And this is also one of the reasons why people get into discussions. It's like, well, why don't you just consume your protein from beans or consume your protein from plant-based meat alternatives? Well, foods provide much more than just protein. And meat provides much more than this protein. So those are things that we're studying, is looking at sort of what is called the whole food matrix. And then we see what is the impact of the foods that you eat on the human metabolome and the nutrigenome, which is basically disease-related gene expression. If you turn on or off these genes related to disease based on the food that you eat, can we then, at least on paper, it should decrease or increase your risk for metabolic disease in the future, depending on what you eat. So nutrient density, there's not a hard definition of nutrient density, but typically it is phytochemicals, vitamins and minerals, omega-3s, triglycerols, amino acids. So if we can pack more of those in, let's say 100 grams of meat, then we have more nutrient dense meat. That is typically how it would be described. So we've been doing our profiling studies, comparing everything from grass fat to grain fat. And I'll talk about some of the nuances in between, because even within grass fat, it matters a lot if you're grazing a monoculture or overgrazing it versus grazing, using adaptive grazing on biodiverse pastures. You still get quite a lot of differences in nutrient density. But let's just start with a high-level data overview. I often hear this, from people. They say, well, grass-fed and grain-fed beef, there's a little bit of a difference in omega-3s, but that's it. No differences otherwise. That comes back to the limited amount of nutrients that have been studied, because yeah, it is true that the protein content is not different. Even the total saturated fat content is not different, but you have an improved saturated fatty acid profile in grass-fed beef. But what we did here was we just looked at about 500 to 800 molecules. These are individual samples in the green and in the gray. So this is in beef and in bison. And if you put the data into the software and this is a PCA analysis, and you ask, well, can you tell me which one's close together, which one is grass, which one is grain? Then the computer can figure that out. The software can figure that out. You can see that the grass samples cluster together, the grain sample cluster together with little overlap. So same with the bison, grass and grain finished bison. What this basically means is that grass fed isn't grain fed and grain fed isn't grass fed. There are substantial differences in small molecule metabolites. The difference is so substantial that it is over 50%. So it's a 50% difference in metabolites and nutrients. And it's much larger than we've previously appreciated. And it goes beyond just omega-3 fatty acids. In a way, cows and bison and other ruminants, they are what they eat. So we see here 800 compounds profiled in the beef, 56% or more different in terms of abundance. Some are higher in grass, some are higher in grain. Higher doesn't per se always mean better. It depends on the nutrient, as we'll see in a little bit. And the same here with the grass-fed and grain-fed bison. But it is clear that there are compositional differences that are substantial. So if you look at a large number of compounds, you see differences appearing. And if this is also for us somewhat surprising when we started to look at this, but if you look at it sort of with everything in science, if you then think about it later, it kind of makes sense. Because let's say if I put a human on a standard American diet or a Mediterranean diet for 3 months, and I would ask you, do you expect a difference in their health outcomes and what circulates in their blood, or even what I could find in their muscle? You probably say yes. If we do that to a lab rodent, then we'd also think that would be the case. But why we don't think that would be the case in larger mammals doesn't make any sense to me now anymore. Obviously, also informed by the data, but 4 or 3 months on a completely different diet during the finishing period results in a different product. So if we look at phytochemicals, which has been an increasing area of interest, phytochemicals, plants, they respond biochemically to sunlight, moisture, herbivory. Phytochemicals are basically plant antioxidants. So there's probably 50,000, 100,000 of them, at least when we know that they can be potentially anti-inflammatory, antibacterial, antioxidant. In the context of human health, there's been some work done on that as well. But if getting these from meat have an appreciable effect on human health, we don't know. We do find benefits for the animal, but these are plant secondary metabolites. So these could be found in plants, typically in high amounts in fresh forages, and they give, for instance, the color to the plant and other things. If you look at it, for instance, we have studied these particularly in the context of things like berries, where they give the color to the berry and the antioxidant components. But when animals consume forages or plants, they also upcycle these phytochemicals into their meat and milk. So we were interested in studying that in terms of that meat nutrient density project. So this is data so far from 60 farms, grass-fed and grain-fed. If we combine all these total phytochemicals, we find on average, and this is some relative concentrations, but they're about twice as high in grass-fed on average than they are on grain-fed. But also note the incredible range here. This would be all the way over from 17 to 146. There's a 9-fold variation here. So this also tells you that grass fed isn't grass fed isn't grass fed. What the animals is fat can have a dramatic impact on these antioxidants, these phytochemicals that we find in the meat subsequently. Same with grain fed. Grain fed isn't grain fed isn't grain fed. What we typically see here, for instance, the most phytochemically rich grass-fed sample is definitely more phytochemically rich than the most phytochemically rich grain-fed sample, but the least phytochemically rich grass-fed sample is still a lot less phytochemically rich than the most phytochemically rich grain-fed sample. And what we find here is that if there's a greater proportion of alfalfa as hay being fed as conserved forage, then we know this is rich in phytochemicals. Not as rich as fresh forages, but still fairly rich to conserved forages, then you are able to rescue some of those phytochemicals. The samples here are mostly from US feedlots where animals are being fed 80 to 90% corn. So, and we know corn doesn't contain much of these phytochemicals. So here we see a clear variation. If we then look at individual phytochemicals, we see that plant phenolic compounds from the forages, they are displayed here. What a lot of times happens with these phytochemicals, they get metabolized downstream, and you can measure these within the given pathway. Broadly, they have antioxidant and anti-inflammatory effects. They can also alter, for instance, cell signaling in our pancreatic beta cells. So they may have some insulin, improves insulin sensitivity and things like that. But I should note that these compounds have particularly been studied in a laboratory-based model. So this could be, okay, if I throw some hyporate or catechol sulfate on a cancer cell, then maybe there's less cancer cell proliferation. But I don't know whether eating this in the context of red meat has an appreciable effect on cancer risk. That's not what we're saying at all. But we do know that these compounds, on paper, have health benefits and can potentially lower our risk of metabolic disease. So having more plant phenolic compounds enriches these. So this is grass divided by grain. So hyporate and catechol sulfate are twice as high. For ethylphenyl sulfate is 20 times as high. Cinnamol glycine, a derivative of cinnamic acid, named after cinnamon, where it is found in high amounts. Cinnamic acid also has health promoting benefits. We see that these compounds are higher, but it's never black and white. Some amines, such as phagamine or piperine, which can have health promoting compounds, we know they're higher in grains, and they're also found higher in the grain-fed samples. But on average, we see higher amounts in grass-fed samples. And we also know that there's a transfer from forage to animals. Animals are what they eat. So if we look here at benzoate and quinate, which are major phenols found in forages, in plants, they get metabolized into hyporate. If we measure benzoate in the forages, free benzoate, we see it's higher in forages. Again, large variation. This includes conserved forages, but also fresh forages from biodiverse pastures. The biodiverse pastures are more over here, conserved forages more over here. But corn-based TMR is lower in benzoate. Benzoate gets metabolized into hyporate in the animal. Hyporate higher in grass-fed beef than in grain-fed beef. Hyporate is a major phenol. It is associated with better gut microbial health in humans. It has antioxidant effects. It can have some benefits on insulin signaling. So, but these are associations. As I said, we don't know whether eating this in the context of grass-fed beef is going to make you materially healthier at this point. But on paper, the nutritional profile, the nutrient density is improved. So there's a clear transfer here from forage to animal, from plant to animal. And it is really, as we often hear the saying, you are what you eat, and it's really as simple as that. I mean, the animals has to get these compounds from somewhere, these phytochemicals, and it gets them from the forages. If they are absent in the the feed that they receive, then they have very little of these compounds. So these are forage samples. Again, some farmers here, we have a large variation here. Monoculture pastures are typically a little bit down here. These are typically a little bit more polycultures. Then what we studied was we also took corn-based TMR, much lower, and then we also had corn-only samples that go into the commodity market and make up a large portion of this TMR, about 70–80%. We see that we're detecting it, but in very low amounts in corn. So any phytochemicals in the corn-based TMR are coming from the hay samples, from the conserved forages, as opposed to the corn. And if there's, the message is never simple, but if there is one simplified message, it is that greater plant diversity results in a higher phytonutrient content. This is due to the fact that when animals are able to consume more forages and have more selection, that they are able to select for more plants and get a broader and a more diverse array of these phytochemicals. And not unlike humans, right? If we are on a very monotonous diet versus a very diverse diet, then we are getting a wider amount of compounds in a broader array of compounds. The animal can also self-select and get the nutrients it needs for itself to medicinal purposes and prophylactically as well, to ward off of any disease. What we typically see with overgrazing is that a monoculture starts to form, and also overgrazing typically reduces some of these phytochemical compounds in the plant as well. So farmers that use more adaptive and rotational grazing practices typically stimulates biodiversity, leaving forages on the field, so not overgrazing. We see that there's a benefit in terms of phytochemical richness, and also in omega-3 fatty acids as well, because we know that wilted or overgrazed grasses, they typically are a little lower in omega-3 fatty acids. So how that looks will differ on every farm, really. What we've done worked with some farmers, they use biodiverse pasture seeding. Others are reestablishing native grasses, such as we have here out west. But out of the east, a lot of farmers are also working on cover crop grazing as well, as a way of helping with soil health, but also providing with more diversity for the animal. Phytochemical richness decreases when animals are finished in feedlots. This was already known in 1987, but this is what we're finding as well in our work. And this goes as quickly as about 45 days. The phytochemicals are cut in half. But as I said, it's never black and white. I definitely don't want to create the impression is that grain feeding is always bad. I mean, some grain byproduct feeding may have benefits. We do find phagamine and trigonylene. Trigonylene is a glycoside present in grains and legumes. It can improve insulin sensitivity animal models, can reduce excess of pathogenic bacteria. We see that there's benefits for some of these compounds as well, and they can be higher in grain-fed animals. We also find higher amounts of B6 and B5 because we know they're rich in grains in grain-fed animals. And it's finding a balance in that. It could absolutely be beneficial to graze crop residues or feed some grain byproduct through the animal to upcycle this. What we've done in the US, unfortunately, we've taken something that can be very good, which is grain byproduct feeding or crop residue grazing, which was common in integrated crop livestock systems in the past. But instead, we put them in feedlots and then push them up to 80% grain. And that might be not be so beneficial, but feeding some grain, high in protein, and other vitamins and minerals, B5, B6, may have some benefits. And there's also some phytochemicals in grain that could have benefits. But it is taking something that's good and finding a balance between that. So here's work from Bison that just got accepted for publication in the Journal of Animal Science and Biotechnology. Again, here we find a benefit for pasture finished, more phenolics, more alpha-tocopherol, more carotene, less advanced glycation end products, which I'll talk about here. But again, it wasn't black and white. We find more vitamin B5 and B6, or gamma tocopherol, which can have some health benefits, more choline, a vitamin, and more taurine, which is an important amino acid in the animals that were finished on pens with free choice access to corn, and they consumed about 50% of their daily intake from corn. So we're following this up now with work. What if we give some corn on rangelands, and we let the animal just select how much corn it wants to eat and how much it wants to consume on pasture? Can we maybe, even get the best of both worlds in that regard, and potentially even some benefits above pasture feeding alone, or at least not compromise the meat quality or the phytochemical richness, as well as animal health? Because what we find is that the pen finished animals that had less ability to move, were fed high on grains, they kind of look like a human with where mammals do, early signs of metabolic syndrome, kind of like a human that would sit on the couch all day eating a refined or a grain-based diet. So we see a lot of overlap in that regard. Decreased glucose metabolic health, more oxidative stress for the pan-finished animals, higher amounts of triglycerols, higher amounts of anti-glycation end products, whereas the pasture-fed animals, better mitochondrial health, which is what you see in human athletes that are active, better long HCl carnitine metabolism, which bring fats to the mitochondria for beta oxidation. So we see this tight relationship between animal health and the nutritional compounds. So a few more slides that I'll go over. Soil-produced metabolites. You often hear, well, what's the relationship with soil health? Well, ergothioneine and histidine betaine are two metabolites that are produced exclusively by soil fungi and microbes. So if we find those in the meat, they must come from the soil. There have been some work done on them being antioxidant, anti-inflammatory, especially in rodent models. And we find higher amounts in grass fed on average. But again, note this incredible variation here that the best grass-fed sample is certainly better than the best grain-fed sample, but the best grain-fed sample is still better than the worst grass-fed sample. So we're collecting soil samples. Sometimes the farmer sends it in, or we do on-field research too. And what we did for this particular data set is, okay, in our controlled studies, we visit farmers, we sample from their pasture, and then we ask the farmer, well, where is your nearest cornfield that you know of? And luckily in the US, they're never far away, because usually the neighbor might be a conventional corn farmer. So all the data that I'll present now after you is within 1 mile apart. So they're paired farms, commercial farms, but this was in Alabama. Here's a biodiverse pasture farmer using adaptive grazing practices. Here's his neighbor growing corn to go into the commodity market. Some of it will go into biofuel. Probably about 30 to 40% will end up in the feedlot. So in the pasture, we found higher soil organic matter. And this is really a model to kind of see, okay, what if we have animals on the land, or what if we grow feed for them on the land and feed it to them in confinement? What does that do for our soil health? Because there is some concern, especially here in the US, with the focus on greenhouse gas emissions, that it's better to grow feed for the animals and stick them in a feedlot and have them out on pasture, because the pastured animals might generate more greenhouse gas emissions. Obviously, that's too narrow, and it doesn't take into account carbon sequestration. We could talk about this probably for another few hours, but anyway, it should go beyond just looking at carbon emissions, of course. But we see higher soil organic matter, higher total exchange capacity, so the ability of the nutrients to exchange between the soil and the plant, higher amounts of zinc, higher amounts of iron, phosphorus, potassium. Obviously, the plant has to get its nutrients from somewhere, gets it from the soil, better soil health, more nutrient-dense plant, more nutrient-dense meat. That is what we're finding so far. Finally, omega-3 fatty acids. Again, here, large variation. The farmers with adaptive grazing practices have the best ratio, so a lot of omega-3s. Some farms, and these were also that we profiled within the supply chain, so store-bought, they're actually quite high. I mean, the data doesn't lie. This is not grass-fed, despite what the label says. They must have been fed some sort of grain. And here we see feedlot beef as well, but here again, grain-fed on a little bit of grain, maybe for 30 days, still has a very favorable profile. Animal health markers. One thing I want to end with is oxidative stress in animals, 4-HNE, 4-hydroxynonenal glutathione. It's been studied probably as a harmful product of lipid peroxidation. Whenever you see the Internal Agency research on cancer, the reason why they consider red meat to be a potential carcinogen is in part because of this compound, advanced glycation and lipoxidation end products. In humans, in rodents, this is associated with a whole host of metabolic diseases. We don't know exactly if it's a true effector or just a biomarker. So is it really causing it? Or if you have disease, then this goes up. We don't know yet. But we do know that if there is a concern about why meat is considered a potential carcinogen, if we can improve animal health, we lower this amount. One example, and this again is sort of an aha moment down the line for us as well, is that advanced glycation end products coming from sugar, glycation, if the animal has worsened glucose metabolic health, like we as humans sometimes do when we're pre-diabetic, if the animal has worsened, animals don't get diabetes, but they do have worsening of glucose metabolic health. If that is higher, then they start off with higher amounts of these products in the raw product, really. So this is another way of sort of thinking about the connection between animal health and nutrient density. Healthier animal gives you more of the good stuff, but also less of what would be potentially considered harmful compounds in red meat. And then finally, we see, and this is interesting for me because I'm trained as a human physiologist. We've studied athletes in our lab as well. We take a small piece of muscle from their outer thigh, muscle, meat, obviously the same, whether we take it from an animal or the thigh of an animal or the thigh of a human. And it's really interesting to see this sort of overlap across mammalian species. A more physically active cow looks more like an endurance trained athlete. A less physically active cow that consumes excessive amounts of grains looks more like a human that has early signs of metabolic syndrome, sort of like your couch potato. So conclusions and directions. Meat from different production systems, it goes beyond omega-3 fatty acids if you're willing to look at 500-600 compounds. Specifically, there's a relationship between phytonutrients in meat. And then what we see is that these phytochemicals, on paper, they may be anti-inflammatory, antioxidant, anti-cancer, brain protective, but their importance in meat and milk on disease risk remains to be further studied. We just don't know that. Yes, we can throw hyporic acid on a cancer cell line and it reduces the cancer, but whether coming that from meat has any appreciable effect, we don't know. My guess would be is that overall diet quality matters, right? If McDonald's switched out its grain-fed burger with a grass-fed burger, I don't think it makes a happy meal, a healthy meal all of a sudden, but it is overall diet quality. It's a further way of getting more nutrients into our diet. And what's particularly neat is that herbivores consume plant species that you and I cannot consume. And oftentimes we find very unique compounds in these that we know can have medicinal properties, but they come from plants that you and I cannot consume. So it's an additional way by which unique nutrients are ingested. And with that, I like to end and welcome any questions that you may have. Thank you so much.
I'll jump in with a question if no one else is jumping in with one. That was really interesting. Thank you so much. You were saying about the particular compounds that you can find in grain that you can't find in the grass-fed animals, that sort of benefit, sort of like an add-on, like you were saying with the diet focus on variation being good. So the more different things they're eating, the better. So what have you found from your research is the best sort of add-ons if you're going to have a grass-fed and something else? You mentioned phagamine before.
Yeah, I mean, so I don't know if there's like a best way. What I typically think is that finding a byproduct that you have access to is the best way to do it. And if you can't graze the corn stalks or the soy plants of your farmer. I think that's a very good idea, right? Of your neighboring farmer, for instance, or if you have an integrated crop livestock system, we're working with farmers who have put the cows on their harvested crop fields, and they consume some of that, put nutrients back. So, but I think the main key is that having some of that in the animal's diet can be a good thing. So, because oftentimes you get bogged down, it's like, oh, it needs to be 100% grass fed, and I don't know if that's, it's good, but I don't think if you feed some grain byproducts to the animal or other phytochemically rich byproducts from fruit and vegetable waste, which now oftentimes goes into landfills, right? Continues to admit. I think it's a great way of upcycling further byproducts, but there's a difference between making that 80% of their diet in a feedlot versus providing some free choice access in a pen or on pasture.
Stefan,
Thank you.
Thank you so much. Pen and my internet both crashed at a really difficult time. So I think that both of you, that you were delivering, and I got a message from Pen saying my internet's died, and then I got kicked out as well. So hopefully it sounds like you were just carrying on brilliantly regardless. So apologies if there was a weird moment when there was nobody hosting. But and that does also mean that I can't see all of the previous questions, but I think there was something from Gillian asking about under research, I think, and I think that was for you, Alice. So I don't know if you can see that in the chat, but because I got kicked out, I can't see it.
I'm here, Nikki. Do you want me to read it?
Oh, that'd be amazing. Thanks, Rob.
It says, could Alice please discuss the relative benefits of EPA, DPA and DHA and why DPA tends to be ignored? Brackets, oily fish is low in DPA, but lean beef, especially grass-fed, is relatively high. That was the question from Gillian.
Yeah, and
Did you catch that, Alice?
I think Stefan probably will add his bit to this as well, but there are 4 main omega-3 polyunsaturated fatty acids. So there's ALA, which comes from plants, and then there's the 3 that are mainly animal origin and mainly most rich in oily fish, such as salmon, mackerel, sardines. Yes, the key thing to know is that humans, and in fact animals, can't convert ALA to the other 3. But there's a lot of exchange between EPA, DPA, and DHA. I think there has been, in general, EPA, the sum of EPA and DHA gives you most of the long-chain omega-3 fatty acids. And it's mainly DHA that you get from oily fish such as salmon. And I think that's possibly why DPA has been ignored. I think there would be an argument for doing the sum of the 3 of them as being the better measure. I am of the opinion, or my understanding is, that still the sum of EPA, DPA, and DHA wouldn't reach the levels that are required to make a health claim. So it wouldn't reach, I think it's 40 milligrams per 100 grams or per 100 calories. That wouldn't be achieved in either beef or dairy. And that doesn't say that it doesn't provide some contribution. And to put it in perspective, a high quality salmon, well, in fact, a mackerel could be as high as 5 grams per 100 grams. So that's huge. High quality salmon would be maybe 2 grams. But what you've got to know is salmon doesn't make EPA and DHA. It actually, like Stefan has emphasized, it depends on what it eats. And we are feeding less and less DHA and EPA to our farmed salmon, which is in reality what we are eating, because it's now a scarce resource with the massive growth of aquaculture. So you are lucky if you get a gram per 100 grams of EPA and DHA in a salmon now.
Yeah, I 100% agree. That's a good point. And to highlight is also, you know, if you look at the EPA and DHA content of beef, you wouldn't think it would move the needle on the amount of EPA and DPA found in our blood, or DHA found in our blood. But because it's fairly rich in DPA and it's effectively converted to EPA, we do see that people that are eating, and this is randomized control trials, I think maybe like 10 or so of them now have found this, not all studying beef, but if you have animal source foods high in omega-3s or rich in omega-3s, either through pasture feeding or through feeding omega-3 rich supplement, after about 8 weeks, people's blood omega-3 levels go up. So it's just a way of further contributing to overall intake. So it doesn't mean that I think you should also be eating fish. That's very healthy, but it's a way of contributing to omega-3s in the diet. And it's the same way I see it's the phytochemicals, right? It's a way of further increasing our phytochemical richness or our micronutrient density in our diet.
Stefan, I could see that Gillian had her hand up, and whilst we wouldn't normally take questions, I mean, we probably could have had Gillian on this panel, also as an expert in this area of research. So Gillian, did you want to come in and contribute further?
I don't want to hog the platform, but it was just to maybe point out to Alice that our study with Pasture for Life meat did reach the threshold, and if we include DPA in our long chain fatty acids, it could be classed as a source of long chain omega-3. We were over that threshold.
Okay, wonderful.
And that was especially on the diverse pastures. So we have a hint of what we might be able to achieve. That's all.
Thanks, Gillian. Well worth highlighting that really important bit of research. And I think Penn talked about putting the link to this webinar recording on the forum, and perhaps we can also attach that paper because I know it's done the rounds of the research group, so we can make sure that's available. I'm just going to, Penn is back with us, but I think isn't able to see the chat, so I'm just going to pick up a few questions that I can see. There's a question from John saying, would Alice recommend full saturated fat grass-fed meat?
The pendulum is swinging and is shifting concerning consumption of fats. So 20 years ago, because of 20 and 30 years ago, because of a very influential study from Ansel Keys, there was a huge move against eating cholesterol and saturated fat, which had an impact on egg consumption, fatty meat consumption, and dairy consumption. That has pretty well been disproven. And the Pure study that I mentioned as a global study looking at the impact of dietary intake and dietary factors and human health concerning red meat also looked at the percentage of calories that come from fat, carbohydrate, and protein, and also broke down the various types of fats. Now, I'm sure Stefan could break them down even further. But what it showed was it was excess carbohydrate, particularly processed carbohydrate or refined carbohydrates, so white sugar, white flour, etc., was really problematic. However, if the percentage of fat or percentage of calories coming from fat was pretty high, it did not seem to be detrimental. And that was the same for unsaturated fats, saturated fats. So really the big bad fat now, sort of big picture, is trans fats in processed and ultra-processed foods. So hydrogenated margarines is really problematic.
I think a good thing to add to that is, I actually took the slide out last minute, but let's see if I can. So what we've been finding is in these very long chain saturated fatty acids is we know that saturated fat isn't saturated fat. Different saturated fatty acids are differentially associated with metabolic disease. So we know palmitic acid has a higher association with metabolic disease, stearic acid neutral, and some of these very long chain saturated fatty acids. So similar to the polyunsaturated ones, right? We see this very long chain ones, these omega-3s becoming enriched. Same thing happens in the saturated fat, and I think this is less recognized in the field at the moment, but some of these compounds like arachidic acid, behenic acid, nonodecanoic acid, which are C20 and up, so longer chain saturated fats, some of these at least are associated with a decreased risk of cardiovascular disease. So higher intakes of these in population-based studies, decreased risk of cardiovascular disease. So we should also start to think about saturated fat as not as an homogeneous category, but pay attention to the individual saturated fatty acids. And we see these, what we think of, I don't like to use the word unhealthy and healthy fat because I think it's an oversimplification, but fats that are associated with better metabolic health, saturated fatty acids become enriched in the grass-fed beef as opposed to the grain-fed beef. So I think that's also, you know, an important nuance that the total saturated fat doesn't tell you the entire story either.
Thanks, Stefan. I know that there was a question, I think, that Maria put in the chat. So, Rob, I might need you to help scroll back through. We're getting real team effort tonight. Just that was asking, I think, about whether Stefan had undertaken any research into plant-based processed food. Can you find that one, Rob?
Yeah, you're good. You're not far off. So, yeah, Stefan, Maria asked, does your team also analyse plant-based meat-free alternatives? And if yes, would you have any results you could share with us?
Yeah, we published a paper on this in 2022, I think, in Scientific Reports. So we did similar metabolomics analysis and we found a 90% difference. If you know, and these were an Impossible Burger and grass-fed beef, or if you pick up the nutrition facts panel, Impossible did a very nice job of matching the protein content, matching the vitamin and mineral content. Consumer may think, oh, I get similar nutrients, but if you drill a little deeper beyond those 13 nutrients on the nutrition facts panel, yeah, you see a 90% difference in metabolite abundance. They are as different as a carrot and a piece of meat would be. So minus the protein maybe, but it comes pretty close. So
with additional salt.
Yeah, with additional salt and things like that. So I always jokingly say, if you well, you could also just eat some meat with vegetables. That's what I would recommend. But if you're eating a double burger, then if you get an Impossible Burger and a beef burger, you get a complementary nutrient profile. That's basically what we found, but they're not comparable. No, nutritionally comparable.
Thanks, Stefan. And I think there was a piece of research that came out that I remember that we profiled as one of the membership newsletters from Pasture for Life that also looked at the different accessibility of those nutrients depending on the carrier food. And so I guess that would have implications as well. Is that right?
Yeah, that's a further nuance. This is that the source of the vitamins and minerals and the various cofactors. Yeah, bioavailability of the micronutrients is likely different as well. Yeah.
Catherine has a question asking, how important is it to minimize intake of omega-6 from plant oils? So Alice, I don't know if you want to take that one.
Not as, I mean, I do know a lot about DPA, DHA and EPA and their benefits. I haven't paid as much attention to the balance between omega-6 and omega-3. And in order to get the balance optimal, you need to increase omega-3 and reduce omega-6. I think it probably comes back to a balanced diet. The optimal diet for humans is an omnivore diet with probably around 30% from animal source foods and 70% from plants. However, you can vary that hugely if you're knowledgeable in order to get the right balance of protein and minerals, vitamins, etc. I think I come back to so often a balanced diet with multiple colours of both fruit, vegetables and of animal source foods. Don't stick to one type of food.
A bit like don't make your cattle eat just one type of feed, put them into nice diverse pastures, right? So,
Yeah.
it feels like all this stuff is kind of, you know, don't want to undermine the extent of both of your huge amount of work that you've done, but it feels like it's kind of common sense, right? To kind of have this balanced diet approach, diverse. What makes it so difficult for us all to accept that?
Yeah, it's a good question. No, I jokingly always say that all I'm doing is verifying what the farmer already knows, usually, but just putting data behind it. But yeah, what's the reason for, I mean, you know, even with the global burden of disease, I don't think it's like, you know, maliciousness of the researcher or anything, but I mean, there is this sort of zeitgeist right now is that, okay, animal source foods are unhealthy for you, they are unhealthy for the environment. And, you know, it's kind of like, yeah, I don't know. It's like almost, you know, you kind of want to go with the flow or the zeitgeist almost, right? Like everyone knows red meat is bad, so it's okay to state that and then think of it as common knowledge. And we kind of not alter data, but maybe we're not as scrutinizing as much as we should either. What happened with saturated fat for a while too, right? Everyone knows saturated fat is bad for you, so I look at it further. So I think that's, yeah, it's a, and then so it's this weird combination of various food industry, maybe, you know, more plants are typically more, you know, processed plant foods are typically more profitable. I mean, it's just a whole host of things that mess with our common sense sometimes, I think. So.
Yeah, I would agree. I think
Yeah.
there's a number of potential factors driving some of the publications that are looking to reduce animal source foods. And I think some comes from philosophy. Some people do not think it is right to be exploiting animals in farms. I think the environmental concerns, somewhat simplistically saying that animal source foods are driving emissions without considering the nature of methane and without considering soil carbon and that it's a cycle. I think profit is a possible motive. There is much bigger margins on processed and ultra processed foods. They last longer. So the profit margin can be huge by comparison with primary agricultural foods. So fruit, vegetables, in addition to fresh meat and dairy. And there is a question in from Pablo about, you know, what's the links with non-animal product diets. And I think relevant to that question is that the biggest funders of the leading institute, the Institute of Health Metrics and Evaluation at University of Washington, to the tune of several $100 million over the last 20 years is the Bill and Melinda Gates Foundation.
thank you for kind of meeting me somewhere in the middle as a social scientist for that last question. I really appreciate that. I'm conscious that we haven't got to all of the questions that were in the chat, but we are at 8:30, and I'm very aware that both of you have got other commitments, and I'm so grateful. And I know Penn is as well. I don't know if Penn's still in the call or if the internet dropped out again, but yeah, massively grateful for your time to contribute to this really important discussion. And I know that, you know, this is, I think, one of the highest attended webinars that we've done this winter, so I know that there's a lot of interest from our members on this, so thank you both hugely for coming and talking to us. And Stefan, we're really looking forward to hopefully hearing some results in the next year or so from some of the samples that we sent.
Yes, thank you both. It's I crashed out, my internet that's normally quite stable went, and I'm very apologetic and very grateful. I reiterate everything that Nikki said. Thank you so much, both of you. It's been a fantastic session, apart from the 15 minutes where I fell out, but that was my fault. Thank you so much. So we'll call it a night. So enjoy the rest of your evening, and it was really exceptional. I can't say how grateful I am. Thank you.
Thank you very much, and nice to meet you, Stefan, as well.
Yeah, nice to meet you. Let's stay in touch. And if anyone has any questions, always feel free to shoot me an email, and happy to answer them.
Yeah, likewise.
Thank you.
Thank you so much.
Bye-bye.